This question looks very simple, but even top students always find it difficult. So let me take you in a step-by-step method of solving this problem. In this problem, we are trying to find the value for x in x power 5 is equals to 8 power x. Okay? To solve this, we make use of a very unique function which is called the Lambert W function. And in Lambert W function, we have that whenever we put a constant like x, exponential x in a Lambert W function, the output is always the x. So all we need to do is to rearrange this so that it suits the Lambert W function standard. So since we have this, the first thing we do is to take the natural log in both sides. Okay? So if we take it to be ln x power 5 is equals to ln 8 power x. The reason why we took the log of both sides or the natural log of both sides is because the natural log always allows us to multiply the power to the what? Logarithm. So what do we have? 5 will now times this power will now multiply. So we have it as 5 ln x is equals to, same here, x ln 8. Okay? Since we have this now, our goal is just to simplify this to bring the variables together and also bring the constants together. To bring the variable together, the first thing we do is to divide through by 5 and divide through by 5. If you divide by 5, what do you have? You have it that ln x is equal to x ln 8 over ln 5 over 5. Okay? So if you have this, we still have x. We need it to get to this side. So we divide through by x and also divide through by x so that x can cancel out x. At the last run, what do you observe we have? We have ln x over x is equals to ln 8 over 5. Okay? So since we have this, we are going to do some initial manipulation here to get the value of x. You know that when we have this, we can now write this as a negative power. That's in the sense we have x raised to the power minus 1, then ln x is equals to ln 8 over 5. The reason behind that is that whenever we have a negative power, it's just 1 over, and that returns us to what? This. And this is actually getting closer to our unique standard, x exponential x. So in this standard, we are lacking what? We are lacking the exponents, okay? So, but you remember that exponents and natural logs are always inverse operation. What I mean is that whenever we have exponent ln x, that the output is always what? X, okay? Reason behind that is that exponent and ln always cancels out. So instead of writing this exponent x power minus 1, we are going to write it to be exponent ln x power minus 1. Okay? Since this and this cancels, we'll be left with x power minus 1. Let's do it here. So instead of writing this, I can write exponential ln x minus 1 into ln x, this ln x, and that's equals to ln 8 over 5. Okay? So since we have this, let's still continue here. Since we have this, you can now see I now have exponents. I'll now have, let's rearrange it first. We have it to be, since multiplication is commutative, the position is never a problem. So we can now have ln x exponential ln x to the power of minus 1 is equal to ln 8 over 5. Okay? But if you look at this, you know in Lambert W function, the two must be the same. But here we have ln x and we have ln x power minus 1. So we actually need here to be power minus 1. And for us to get that, we multiply through by minus 1. So what do we get? Minus 1 into ln x, okay, exponential ln x power minus 1. We are multiplying to both sides. So we are now having it to be equals to minus 1 into ln 8 over 5. Okay? So if you have this, remember the laws of exponents, which we said that whenever we have a to the power of, let's say logarithm log a to the power of minus 1, that is the same thing as minus log a. Okay? The power multiplies the log. You know the rule. So we are going to apply it here so that this negative sign becomes the power. So we have it as ln x power minus 1 exponential ln x power minus 1, okay, is equal to minus ln 8 over 5. This term and this term are now the same. Okay? Since they are the same, you can now take the Lambert W function in both sides. So if I take it, the Lambert W function of ln x power minus 1 exponential ln x power minus 1 is equals to the Lambert W function of minus 8 minus ln 8 over 5. Okay? So if you have this now, since if these two are the same, the output in Lambert W function still remains this. So the output will now be ln x to the power of minus 1, okay? And that's equals to the Lambert W function of minus ln 8 over 5. Okay? So if you have this, this is now a minus power. So what do we do to get rid of the natural log? We have to take the exponents, right? So if I take the exponents of the ln x power minus 1, and I should also take the exponents of the Lambert W function of ln 8 minus ln 8 over 5. Okay? So that this reduces this to be x power minus 1, and that will be equals to exponential the Lambert W function of minus ln 8 over 5. Okay? So if you have this, this is just a minus, which means 1 over. Okay? So we can write it as 1 over x is equals to exponential the Lambert W function of minus ln 8 over 5. Okay? So to get the value of x, since this is the inverse, that means our x is equals to 1 over the exponent of the Lambert W function of ln 8 minus ln 8 over 5. And that's the what? Answer. Okay? This is just the answer. If you found the video interesting, do well to like, subscribe, and share to get notified anytime I drop a new video. See you next time.